Hi, I'm Brian Walsh. I'm making this recording for Environmental Science 118, and my topic is the Internet of Things and sustainability, and more specifically, how IoT can play a role in environmental and client sustainability. So, what is the Internet of Things, or IoT? It's really a network of physical objects or things that are embedded with sensors, software, and technologies. And these things are connected over the internet, much like our smartphones and our laptops and our tablets. But these devices are connected in order to drive some kind of data-driven insights. And the purpose of all this is to increase the efficiency, productivity, and sustainability of many different vertical markets, use cases, and domains. I'm showing a lot of examples here on the left, but let me just pick out a couple. Smart cities, for example. Cities are installing connected parking sensors to increase the efficiency of parking space in the city. This also increases revenue to the city. So parking applications can determine at any moment whether a space is occupied or not, and for how long. This is actually also helpful to drivers. In some cities, they've got displays up at the head of the city, being able to, in real time, inform drivers, how many spaces are available on that area. This cuts down driving around. Some estimate that 40% of the traffic in the city are just people driving around looking for parking spaces. So the more you can optimize that, the less gasoline you're wasting and less carbon dioxide you're producing. Cities are also doing smart lighting, which allows them to control from a central point all of the thousands of streetlights in the city. Looking at smart buildings, a lot of cities are mandating carbon neutral plans from any new buildings built. I know in Boston that is the case, also in other cities around the world. And by adding sensors, buildings are able to be smarter in how they consume electricity, how the HVAC systems and air distribution systems work, and that's going to cut down energy usage. Skipping around to agriculture, we're seeing livestock tracking being enhanced by sensors connected to the livestock. We're also seeing applications for smart irrigation and fertilization that cuts down the use of both water and fertilizers as well as pesticides. Transportation is also an area that's quite embedded with IoT. Fleet management is an application where a route of a truck is optimized based on understanding traffic conditions, understanding pickup and drop-off locations, and other attributes that can improve the efficiency of the operation of a fleet. So those are just a couple of examples, but the point is that IoT allows sensors and information from a sensor, which is normally not digitized. It enables that information to be connected to the digital world, to the internet, and to an application that can do something with that data. So let's look just a little more detail at three of these applications to get a better understanding of what IoT provides. I mentioned street lighting. Street lighting is the most expensive line item in most city budgets. So to be able to see all of the street lights that are connected over a network to an application or dashboard, the city can control those lights. They can determine which lights are not working. Lights can be dimmed overall or in certain areas of the city for cost and energy savings, or they could be turned up to full intensity when a high level of pedestrian traffic is detected by the onboard motion detector for additional safety. Smart water meters, for example, are also another good use case. Leaks can be detected in real time, so repairs can be made and water not wasted. Otherwise, a leak might not be detected until the homeowner or building owner gets a surprisingly high bill at the end of the month. So this improves water conservation. Many cities are installing smart waste bins that are connected and can report how filled they are back to that application, which will then inform the fleet management system whether or not to send a trash truck to go pick it up. So this image is a summary of what's called the United Nations Sustainable Development Goals, or SDGs. And I want to use this as a template against which to test my hypotheses that the Internet of Things can play a role in environmental and climate sustainability. If you're not familiar with the SDGs, they were adopted in 2015 by UN member states. They consist of 17 goals, as shown here, within which there are 169 quantifiable targets. And it really is a blueprint for prosperity for the planet. It represents really a call to action by all member countries in a global partnership to achieve these goals. And every year the UN publishes a progress report against these goals and targets. So in September of 2022, a consulting company called Transformer Insights did a study where it mapped common IoT solutions against the 17 SDGs. So on this chart on the right, you can see across the bottom several IoT solutions that we've discussed previously, like fleet management, smart cities, smart agriculture, smart grid, smart buildings, and map them against the 17 goals shown on the left side of this chart. And by doing a look at deployments and case studies and solution focus, they were able to map that relevance. And you can see that IoT has a significant impact, especially in areas where energy and fuel consumption and CO2 emissions are reduced because of the addition of IoT applications and devices, and also enhancing sustainability of cities, industry, and infrastructure. Across number 9, industry, innovation, infrastructure, that probably had the biggest impact, as well as climate action. And it's really to help countries move towards a more sustainable industrialization. Other areas that were impacted include sustainable cities and communities, climate action, and responsible consumption and production, where the majority of IoT solutions impacted as they decrease greenhouse gas emissions, reduce material waste, and positively impacted in the reduction of the consumption of one or more forms of energy. We can also look at this matrix vertically as well and see solutions like smart agriculture that can bring benefit to multiple SDGs, including but not limited to the goal of zero hunger. So let's drill down a little deeper on sustainable agriculture and look at a specific use case of precision farming or precision weed control. I'm showing here a tractor sprayer with connected optical sensors that come from a company called Trimble, as one example of a company that provides this type of equipment. And you can see the units, these optical sensors. They have optical devices, they have computing processing power, and they're network backed to a central application that allows for a more holistic and global view of the farm operation. In this case, the way these optical sensors work, as they move forward, they see the weeds and record that location in the application database. And then the unit is able to signal to the attached spray nozzle to deliver herbicide precisely where the weed was found. So this obviously lowers the cost of weed control. Less chemical and herbicide is used according to the manufacturer. It could be up to 90%. And because it logs every weed sprayed, it creates detailed maps of the farm for further analysis by the farmer to understand where there are issues in the farm. Similar technologies are used for spraying fertilizer, for seeding, for irrigation, and all of these lead to more optimized agricultural practices. Less inputs are used, less CO2 is emitted by machinery, and costs ultimately lowered, which is a win-win for the farmer and the environment. So I hope this presentation gave you an understanding of how the Internet of Things, or IoT, can play a role in enhancing environmental and climate sustainability. Thank you for your time.